Hello everyone. So I hope the last lecture was informative and you got a bit of idea of how the variables work in Golang. In this lecture we'll study more about arrays and slices, what actually are arrays and slices, and what is actually the difference between both of them, and when to use which uh, data structure. Correct. So let's move on with this. First of all, arrays. So as you know, arrays are collection of data points of similar data types. So suppose you have a list of numbers like 1 2 3 4 5 6. So generally this is called an array, that you have a list of numbers or a list of names. So this can be also called any other data structure, but arrays just signify a collection of data points of similar data types. Correct. So now we'll talk about the four things: array declaration, their comparison, the multidimensional arrays, and in which cases array panics occur. Panics, you can think of panic like a compilation or a runtime error, which usually occurs during the execution of a program. So yeah, let's just start with variable declaration. So the most basic type of variable declaration for arrays is var x 3 and int. So now we have an array of size 3, and let's say if I print this fmt import package println x, right? I'll just try to run this. Correct. So what it does is makes an array of size 3 with all the values being 0. That is the initial value. So suppose if I've made it as string, and now it will just show empty array, like with empty, yeah. As you can see, it is of, you can't figure out it's of size 3 because it's mostly the empty string, but that's what it does. It makes an array of the size length that's provided here, and with the initial value or the 0 value of the data type that's attached to it. Cool. Have right now some initial values. Yeah, so suppose, let's say if you have some initial values right now, and then you want to specify the array with those initial values, what you can do is you can just make it like this: var x is equal to 3 int, and then 1 2 3. Now if I just print it, I'll just try to run it. Great. As you can see, we have an array of size 3, and the values in it are the values that I've initialized. So suppose, let's say if I make it of size 4, and now if I run it, so the first 3 indexes will be filled with the values that we have provided, and the fourth index or the last index will be of value 0, since we haven't provided anything for it. Yeah. Okay. So now let's say if I put size 2, I think that should cause an error. Yeah, as you can see, we have an error here. Let's just try to compile it. Yeah, index 2 is out of bounds. Great. So this is also a type to initialize variables when you know the initial values. Cool. So suppose now you have to make an array of something like 0 0 0 1 1 1 1 1 2 2 2, and then again 0 and 0. So suppose basically you need to fill some parts of the array, and then you need to keep some parts of it as empty. So this is known as a sparse array. So you can also initialize it in some form. I'll just give you an example for this. So suppose this array, let's say that size is 12, and then int, and then what you will have to do is you'll just have to initialize the value that from which you want to start, and then from which index do you want to start, right? So suppose it's like this: 1, let's say the initial value, and let's say then from there on you have to start from the index 5 4 6, and let's say then from 7 8 9 10. Sorry. Yeah, so I'll just run this. Great. As you can see, from the fifth index 0 1 2 3 4, yeah, from the fifth index we have added 4 and 6, and from the seventh index we have added 9 10. And suppose, let's say if I try to do an overlap, let's say I put 6 here, it will cause an error because there are two values that are being put in the same index and it's a duplicate index, right? So this is another way to initialize an array. Suppose we need to initialize an array like this: 0 0 0 and then 1 1 1. So what we can do, let's just comment it out. So what we can do is, first of all, the size will be 6, and then from the third index I'll just do 1 1 1 1 1. So that will make a sparse array. Great, now I'll just run it. Great, as you can see, we're getting the output that we wanted. So this is another way to declare an array. Also, now let's say you want to initialize an array, but you don't want to give it an exact size. You want the Golang compiler to take in the length of the initial value that you're providing and then use it for the size. So what you can do is var x is equal to int 1 2 3. Now, so the main usage for this is, let's say if you want to make a 2 3 and then 10 4 6 and then 31 2 3. So in this case you won't let's say you have many values that you need to fill in a sparse manner. So it's ideal that you put the 3 dots and then let the compiler decide the length of the array rather than you hard coding it every time. Yeah. So I think this will give you a longer array, as you can see. Great. Great. So we've talked about array declaration. Now let's just talk about array comparison. Great. So you can generally use the equal to or the not equal to sign to compare the array values, the arrays, yeah. So suppose I have an array where x is equal to 3 and 1 2 3, where y is equal to 3 dot dot and 1 2 3 fmt dot println x equal to y. Great. Now when I'll just run this, it should show true. Yeah, because both the arrays are of same size and both the arrays have the values as the same at each corresponding index. So what it does is it checks for the size, it checks for the value at each index. Suppose let's say if I twist it to 2 and this I make 1, the size will give true, but this it will give false. Let's just run it. Right, and then let's say if I make it of size 4 and then I do this 1 2 3. So we'll talk more about this, why this is giving an error. So as you can read the error, invalid operation, x equal y, mismatch types 3 and 4 and like, yeah. So we'll talk more about this later. Now multi-dimensional arrays. So you can also make multi-dimensional arrays in Golang. Although Golang only has one-dimensional arrays, but you can simulate the one-dimensional and make multi-dimensional arrays. Like let's give you an example. Like making values like this. Let's try to run it. Okay, so as you can see, we have a multi-dimensional array of size 2 and each size 2 has an array of size 3. So this is a multi-dimensional array. Correct. Now Yeah, so now we'll just talk about panics and array panics, how they occur and what they are in arrays case. So panic usually means a runtime error that occurs when you're trying to run a program, and the whatever. So now let's just look at first of all this case. So equal to 3 int 1 2 3 fmt.println x and 3. So this will give you a compile time error. This it won't let the code to compile because we're using the hard coded value 3, right? But let's say if I try to do something like this, yeah, so let's say if I try to do something like this, so this will give you a panic because at the compile time this looks okay because the value isn't attached to it. This gets attached to it at runtime. So let's just see. Yeah, the panic has occurred. Panic runtime error, index out of range for this. So now let's say if I put 4 in it, similar case, this will give you a panic. So this is basically a runtime error that occurs in Golang. Let's put 3 also. Same. So I hope the panic in arrays, how they occur, is clear. Now, yeah, great. So now we'll just talk about arrays and why is it too rigid to use arrays directly. One thing to note here, as in the case earlier when we were trying to compare 3 length array and 4 length array, one thing to note here is that Go considers the size of the array to be a part of the type of the array. So suppose let's say you have an array integer and of length 3, so they both mutually make a type. And let's say you have an array of length 4 and integer type, so both the types are different. You can't compare or make a value from one to another. So this is what makes the arrays too rigid in Golang. So let's just talk more about it or see how it works in the code. Or let's say if I have the value var x is equal to 3 int 1 to 3 and then var y is equal to 4 int 3 4. Now let's say if I just want to make x equal to y, Go wouldn't allow me, so it just gives you an error. I'll just try to run this code, see how it goes. Yeah, cannot use y as 3 into value in assignment. So this is like a very rigid structure in Golang where you have to make sure that both the data type and the length of the array are same, just to make sure that they both are compatible. Yeah, and this also means that you cannot use a variable to specify the size of an array because types must be resolved at compile time, not runtime, because the length of the array should be known at compile time. So let's just take this to example. Var x int is equal to 4, supposed to be the length of the array. Now var a is equal to x int and then I'll just put 1 2 3 4 fmt. Yeah, ideally this should work because you're just taking a value at x and just putting it here, but what happens is this value x becomes 4 at runtime and then it attaches itself here at runtime. So basically at compile time this array here remains like this 1 2 3 and 4. At runtime it becomes 4 1 2 3 and 4. So Go needs this kind of structure at compile time itself. So when I'll just try to run it, just see when I try to run it, what error does it give? Yeah, invalid array length x. Yeah, so I think how do we deal with this rigidity? And also let's say if you want a function that is in any length of arrays, we can't do that in Go because let's say if I make a, suppose let's say if I try to make a function which takes in length 4 of an array. So suppose function array x4 int, and then I just do fmt.println x. Suppose let's say if I want to use this and I'm not sure about the length of the array, var x is equal to 3 int 1 2 3, and then array x. Great. So now let's say if I do this, first of all for length 4 this should work, yeah, but let's say if I do it for length 3, then this wouldn't work. Yeah, because the variable type it wants is 3 int, and the variable type that it the variable type it wants is 4 int, and the variable type it has is 3 int. In that case, so you can see the rigidity here. So that to resolve this, what's the solution? The solution is slices. We'll talk more about slices in the upcoming videos. So thank you guys. I hope this video was informative. Any sort of comments that you have will be appreciated. Bye bye.